Priya. Today we are going to discuss some concepts in physics. Okay, fine. So do you all have interest in physics? No? Very nice. Why? What makes you physics to feel tough? May I know the reason? Derivations. Apart from the derivations and formulas, if you know the concepts, it will be the most interesting subject in science, isn't it? Isn't it? Okay. So today we are going to discuss some basic concepts which are related to NEET. Okay, and it has more weightage in your NEET exam too. Fine. So can you imagine our world without these lights, fans, projectors, TVs? Can we? Imagine panla. We can imagine. But can we live? So what is the basic need for those to operate? Yes, please. Yes. I'm not audible. For the fan to operate, what we need? Yes, electricity, isn't it? So in physics, there are two branches in electricity, isn't it? You have already studied, am I right? Huh? So what are those two branches? Static electricity as well as current electricity. So what are the difference between these two? Electricity ellame electricity dane. Why they have divided into static electricity and current electricity? Properties differ. What kind of properties differs?
Fields created
Huh?
fields and forces experienced
Fields and force by them are different. Okay, fine. So this electricity is broadly divided into static electricity as well as current electricity, isn't it? So now the static electricity deals with the branch of physics. It deals with the study of electrons which are at rest. Static means stationary, isn't it? So the electrons which are rest comes under the static electricity. We will be studying the properties and characteristics of electrons which are all at rest. In case of current electricity, the electron will be in motion and we will be studying the characteristics of those electrons, isn't it? So a term in English called current is also known as ampere.
Flow, movement.
Yes, exactly, flow. Let you consider the water in the river. It is flowing. So the water can be told as water current. So the gases in the atmosphere are flowing. So it is called as air current. Similarly, in a conductor, the free electrons are moving. That free electrons, flow of free electrons is called as electric current. Okay. So are we able to measure these electric current? Is it a physical quantity?
Yes. 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 Yes.
How can we measure it? Using ammeter. Do you know the formula for that? Do we have the formula? I is equal to? I is equal to? No.
V by R.
No. Huh? Yes, exactly. So it depends upon the charges that are flowing in a particular area. So current can be measured using the amount of charges flowing in a particular area for particular interval of time. Let us consider a conductor. So this is a conductor, okay? In this conductor, is this the cross-sectional area?
Yes.
Am I right?
Yes.
So when the electrons are moving, it passes this cross-sectional area, right? The electrons will pass through this cross-sectional area. So in this area, some amount of charges will flow for some particular interval of time, isn't it? That amount of charges are told as
Current.
current. Okay, so the formula can be written as I is equal to Q by T. It depends only upon the amount of charges as well as time, and it never depends upon the area of cross section. எவ்வளோ ஏரியா இருந்தாலும் the same amount of current will flowing through it. Okay, and we have the another term called current density. What is this current density? We have mass densities and it's same.
By area of cross section, you have resistance. Resistance, it can reduce the current.
Of course, yes, good point. But sit. So this area of cross section increases means the resistance value gets decreased, which results in the
Increase current.
flow of current, increase in the flow of current. But what happens to the length?
Length decreases.
Length decreases, though it will also have impact in it, isn't it? So it will also have the impact in the flow of current. Okay. Okay, now the current density.
But we can consider two wires of same length but different cross-sectional areas. And according to this formula, they will have same current flow.
Same material,
Same material, same
but
different
same length,
cross-sectional area.
but different cross-sectional area based on the resistance. Yes,
No, based on this formula, QAT, they will have same current flowing through them.
they will have the
Same current flowing through them.
same current flowing through them. Yes,
But using that formula, we will have different currents flowing through them. As one is more cross-sectional area and another is less cross-sectional area.
but mostly the current will not depends upon the cross-sectional area, but I will go through it until. Sure. Thank you for your doubt. Next is current density. What about this current density?
Current per unit volt.
Current?
Per unit volt.
Yes. See, I told you that this is the cross-sectional area, isn't it? In this cross-sectional area, I'll consider a particular area and I'm going to calculate the amount of charges in that. That is named as current density in a particular cross-sectional area. So that is given by I by A. Current in a particular cross-sectional area is given as current density. Okay. Okay. Now, I have not applied any field to the conductor. Will there be movement of electrons in the conductor?
No. Yes, random movement.
Yes. Do we have motion in the electrons? Will the electrons move if there is no potential difference is applied across the conductor?
Yes, random movement will be there.
Electrons will be in motion. It is purely because of the, yes, the energy, internal energy it has. Okay, so that velocity, that motion because of that internal energy is called thermal motion. Thermal motion. If it is moving means obviously it has some velocity, isn't it? What is that velocity? Huh? Electrons drift velocity.
Yes.
That is called thermal velocity. Thermal speed we consider, and because of this thermal speed we can calculate the internal energy of that electron. It is moving because of some energy, isn't it? That energy is calculated using if some object is moving, we can calculate the energy, right? What type of energy it is? Yes, kinetic energy. So that energy is given as 1 by 2. Can you? M B square. Let this be the average value. Okay, I am taking here as RMS value, which is the average value. And this energy value is also given by the scientist Boltzmann, isn't it? Boltzmann equation. The energy,
Boltzmann constant.
the energy equation. Yes, 3 by 2 kB T. 3 by 2 kB T. Both the energies are same, so I can equate this kB into T. Okay, so from this we can calculate the thermal speed of the electrons when the electric field is not applied to it. Okay, so V 2 get cancelled, isn't it? So V RMS squared is equal to 3 kB T by M. So what will be the speed, thermal speed? What will be the thermal speed here? V RMS will be root of 3 kBT by M. And this will be in the order of 10 to the power 5 meter per second. Okay. So once the electric field is applied to the conductor, what happens?
The electron, the charge
Move in a uniform direction.
When the electric field is not applied, they will be in the random motion, isn't it?
higher potential, lower potential.
When the field is applied, the electron starts to move from
Higher potential.
to lower potential. So they will be in the uniform motion. When they are in random motion, each electrons have its own direction, isn't it? There are infinite number of electrons, and if we calculate the total velocity of that, I mean the average velocity of that electrons, we get the answer as, if they are in random motion, velocity, this is speed. I'm asking about velocity. The average velocity of the electrons when the electric field is not applied is 0, because they have motion in all the direction, all the 360 direction. If one is moving in positive x-axis, another one will be definitely moving in the negative x-axis, then the total net velocity, average velocity will be 0 if they are in random motion, isn't it? But when the electric field is applied, what happened? They start to move in one particular direction, that is from higher potential to lower potential, isn't it? Now it has the velocity. That particular velocity is called drift velocity. So during motion of electron, during the movement of electron, it will collide with some other electron or with the lattice position, isn't it? So before two consecutive collision, it travels for a finite interval, finite length, isn't it? Finite length. That length is told as see here one collision, and after this collision it travels to some particular distance before the another collision. So this length is called as the average distance traveled by the electrons before two consecutive collision is called as exactly mean free path. Mean free path, and it is represented using the symbol lambda. Okay, what about the time taken before? Yes, relaxation time. What is the symbol for this?
Now,
So when the electric field is applied, some force will be applied to the electrons to move in one particular direction, am I right? So that force can be calculated using the formula F is equal to, in the first 2 units itself you have studied. EQ, yes. Capital EQ, or else we can consider the charge of one electron is, it can be represented using the symbol minus E. Instead of Q, I have written here minus E. Okay, into capital E. And in the 11th, you have studied the equation of this force by Newton's second law, isn't it? If an object is accelerated, the force can be written as m into A. So now this acceleration can be written as A is equal to, leave this, just rewrite these two. A is equal to minus E into E. M is the mass of the electron, isn't it? Okay. And we know the equation of motion. 3 equations you have studied. So V is equal to final velocity is equal to initial velocity plus the electrons will be in acceleration ATU plus AT. So instead of this A, we can substitute here. Okay. Instead of time, we can substitute the relaxation time. So what is U here now? 0. Why? Because?
It has just collided.
Yes, just it is started to. Before the application of electric field, the velocity was 0, isn't it? Soon after the electric field is applied, it has some acceleration. So this U will be 0 and minus E divided by m into tau. So this velocity is termed as drift velocity Vd minus E by m into tau. And this drift velocity will be in the direction opposite to that of electric field. Vd is proportional to E, but here minus symbol is there, no? Velocity is also a vector quantity, electric field is also a vector quantity. So in this equation we have minus symbol. So this indicates that Vd will be opposite to, velocity of the electrons will be opposite to that of electric field.
How practically Vd is out?
Exactly. So the electrons so this is the conventional current direction, isn't it? What will be the direction of electric field here? Huh? Positive to negative. So I will be in the direction of like this, isn't it? But the current is moving like this. Am I right? This is the conventional current direction. Conventional current direction is like this. So velocity will be also opposite to that of the electric field. Vd will be like this. Conventional current, based on the conventional current direction, the velocity will be opposite. Okay. And you know that Ohm's law, isn't it? You know the Ohm's law, am I right? Can anyone say the Ohm's law? Yes, at constant temperature, voltage is directly proportional to I, resistance of inversely proportional to resistance. Voltage is directly proportional to the current flowing through the conductor when the temperature of the conductor is maintained constant, isn't it? So temperature should be constant. Is this the universal law? Does it hold same for all the types of materials in this world or in this universe?
Constant temperature.
At constant temperature only I am asking. Does it hold?
Yes. Constant temperature. Some materials may have different.
Depends upon material. What type of material can hold this law? Conductors. What about the semiconductors as well as insulators?
At some temperature, semiconductors can also hold fluid.
See, I told the temperature is constant. I am not going to change the temperature.
No, for some temperature which can be held constant. Semiconductors also obey this law.
Semiconductors?
Also obey this law
Oh, really? Really?
for some temperature.
Okay.
Diode does not obey.
Diode does not obey this law. Yes, because it is a semiconductor. Insulators will also disobey. Okay, so what's he doing? Huh? Am I rocking? Okay, fine, listen. So voltage is directly proportional to current when the temperature is maintained constant. This holds good for ohmic conductors. What is this ohmic conductors?
Which obey Ohm's law.
Yes, that obeys Ohm's law. Okay, for semiconductors and insulators, V is not proportional to I. So in the graph itself you have studied, isn't it?
Yes.
Vi. For ohmic conductors it will be like this. For diode it will be like this, isn't it? Diode is a semiconductor which starts to conduct when it in one direction.
Unidirectional.
Yes, unidirectional. It allows only unidirectional path of current. See, resistors means if I change see, initially it was like this. It will conduct now. Resistors will conduct, isn't it? So if I change this direction, will now it conduct? Huh? The direction will be changed and it starts to conduct the current, isn't it? The resistance will conduct, isn't it? But in case of diode, it will not allow this.
You only allow one type of motion.
It allows only because it has anode and cathode in it, it just accepts the electrons from one side and will not accept the electrons from the other sides. One side electrons, I mean the flow of electrons will be allowed in one direction only, that is from anode side. So it has two electrodes, anode and cathode. Diode is resistors you have, right? The same thing, diode. Resistors मारे diode or element da. Resistor is an element which you are using in your lab, isn't it? Diode is also a same type. You can see in many electronic devices. LED bulb.
LED.
All the electronic devices have this diode. Just to oppose the flow of current if the... Sorry, sir? No, actually. So when the temperature differs, the resistance of the material will vary, isn't it? So the resistance of the material not only depends upon the temperature but also depends upon the type of material as well as other type, nature, both are same. Length as well as area. So this R is proportional to so V is equal to IR, right? This R is material specific and temperature specific and it is also directly proportional to length of the conductor as well as inversely proportional to the cross-sectional area of the conductor. So to remove this proportionality, we need to add a constant called rho, which is nothing but resistivity, isn't it? So based on this, you can expect many questions in NEET, like by varying the length and cross section. If the volume of the material is maintained constant, volume is maintained constant. If I increase length, what happens to area? Area decreases. Area of cross section of the wire decreases. The thicker material, if I stretch it, I'm sorry. If I maintain the volume of the material is maintained constant. Let you consider a wire. Okay, it has some thickness and cross-sectional area. If I stretch that material, what happens? The thickness decreases if I increase the length. Am I right? So length increases, area decreases. So now initially R1 is the resistance of that material, rho L1 by A1, isn't it? Rho L1 by A1. Now I have stretched it and it has increased to length L2. So will it resistance change? Exactly. It will change, isn't it? R2 is equal to rho L2 divided by A2. So the new resistance you need to find now. How can we do it? R1 by R2 rho, this is not E, this is rho, resistivity, L1 by A1 divided by rho L2 by A2. See, I already told you that volume is maintained constant. So this A can be written in terms of length and volume, isn't it? How can we write that? Volume is equal to A into L. So rho L1 by A1 can be written as B is equal to AL. Up L1 can be written V by L1. V by L1. Same way, rho L2 divided by V by L2. Here, what are the things which get cancelled? E, rho, as well as V, right? So this can be, this can be written as, see here is L1. So if it is reciprocal, L1 squared, same way here, L2 squared, isn't it? So R1 by R2 equal to L1 by L2 the whole square. If the material is stretched and if you are asked to find the resistance after stretching, you can use this formula. Some conditions are also there like this. If at all length is not given but area of cross section is given, here we can use this formula if length is given. Area of cross section kudutha. So R1 by R2 equals rho L1 by A1 divided by rho L2 by A2. We know only A here. A1 and A2 are given. So how can we rewrite this equation? Instead of L1 we can write V by A1. V is constant, isn't it? Similarly, rho V by so here also rho get cancelled, V get cancelled. This can be written as
A1 square, right?
See, this is 1 by A1 squared,
Into
1 by A2 squared. This can be written as A2 squared by A1 squared. A2 squared by A1 squared. So R1 by R2 equal to A2 squared by A1 squared. Here R is not given, but the radius of the conductor is given. How can we convert this formula? Instead of this, we can write pi into R2 square divided by pi into R1 squared, isn't it? The whole square. Because area squared, isn't it? So pi get cancelled and R2 by R1, the whole power 4. Okay, see, if L means squared, area also squared, but length, it is in the power of 4. If D is given, how can we rewrite this formula? Same, exactly, because R is equal to D by 2. So 2 get cancelled. So D2 by D1 the whole power 4. Okay. So based on the given data, you can use this formula and apply. Do you have any doubt? Shall I continue or? So we have calculated the resistance in the circuits which are parallel or series. எத்தனை resistance கொடுத்தாலும் depending upon the connection we can calculate it. Those are all just external resistance, isn't it? But we have the term called internal resistance. What is that internal resistance? Huh? Internal resistance?
Within a resistor.
Within a resistance. Within a cell, exactly. So you have a battery with yourself, right? You have seen the battery, isn't it? Battery la enna irukum? What are all the things we have in battery? Positive terminal and negative terminal. Inside the battery,
some solution will be there.
that solution is called electrolyte. And apart from that electrolyte, we have two plates. What are those two plates?
Pure and impure plates.
Inside the battery, apart from electrolyte, we have two plates, isn't it? That plates are called electrodes. Positive, if the electrode is connected to the positive terminal, then it is called positive electrode. That positive electrode is also called as yes, anode, because it attracts anions towards it. Anodes attracts anions towards it. What about the cathode? It is connected to the negative terminal of the battery and it attracts cations. Positive ions attract one. It attracts the cations and so it is called as cathode. So in between the anode and cathode there is some distance, isn't it? So the ions tends to move from one electrode to another electrode, right? So during this movement it experiences some resistance or else it experiences some collisions in between, isn't it? Based on that, resistance will be present in between the two electrodes, am I right? So that resistance is said to be internal resistance and it is inside the cell or battery. So how to calculate that? So this is the external resistance and I have written it in capital R. The internal resistance I can use as small r and this is E. What is this E? EMF, yes, electromotive force. Because of this, the charges moves throughout the circuit. And we have two terms, right? EMF as well as potential difference. EMF as well as potential difference. What are these two terms? Are these two terms representing the same or different? EMF potential difference ஒன்னு தானா? EMF resistance,
Internal resistance.
sorry, applied within the battery. So out, what about the outer circuit?
Potential difference.
What is the difference between those two?
Internal external.
That's inside the cell and it's placed for internal resistance. As a potential difference, place the difference between potential inputs and
So normally you know that voltage is nothing but work done by a unit charge. Am I right? Voltage is nothing but work done by a unit charge. Am I right? So we use the term voltage for EMF as well as the potential difference. But both these terms are different, isn't it? So the EMF is the one which makes the charges to flow throughout the circuit. If I take out these resistance, this is a load, isn't it, which consumes power. So now this EMF just gives the force to the electron, energy to the electron to move throughout the circuit. But if I include a resistance here, a load here, or else lamp. So on receiving the charges, what does it happen? What happens here? It is bulb, okay. Lamp starts to glow. So what is happening here? The charges are used up to glow this light, right? So the potential difference is the work done by the charges in unit charge. This EMF makes the charges to flow through the circuit, but this potential difference makes the charges to get useful work, to do the useful work. If I replace fan, what happens? It starts to rotate, it spins, isn't it? Some useful work will be done across the load, and that work done by the charge is told as potential difference. So in simpler terms, this EMF is the voltage across the battery, whereas potential difference is the voltage across the load. It may be resistors, bulbs or fan.
But the potential difference is used for potential difference is used to conduct the electric
Energy to some useful work.
what it is used to conduct the charges from wire to
While conduction, it makes some useful work. If there is no potential difference, what happens? It will not be operating, right? When we create some potential difference, the charges starts to flow, and that charges will do some work, which in turn converted into another form of energy. That may be light energy, heat energy, or mechanical energy. Okay. So, no, it's not. Thank you.